Welcome. Today we're going to be going and it says given that the cosine of a plus b is cos a cos b minus sine a sine b and the cos of 2 theta is 2 cos square theta minus 1, show that cos 3 theta is that formula right there. Now remember, when it gives you something, that's typically what you're going to use. All right, so they're giving you hints. So first we're going to start with the cos of 3 theta. The cos of 3 theta, starting with that, we know that the cos of 3 theta, it's equal to, since we're doing a proof, I like to write left-hand side. That's what my left-hand side is. My left-hand side is equal to cos 3 theta. So cos 3 theta is equivalent to cosine of 3 theta can be written as the cosine of 2 theta plus theta, right? Cosine 3 theta can be written as a cosine of 2 theta plus theta. Now, they just gave us that we can utilize the compound angle formula and express this as cosine 2 theta times the cosine of theta minus the sine of 2 theta times the sine of theta. Nice and easy. We can express it this way. Nice. Again, it went further to tell us to use cos 2 theta as 2 cos square theta minus 1. So this cos 2 theta now, we can rewrite that as cos 2 theta right here. This is 2 cos square theta minus 1. So what we're going to then get is 2 cos square theta minus 1. And that is being multiplied by cos theta. And then we're subtracting. Now I can go ahead and tell you that sine 2 theta is 2 sine theta cos theta. Sine 2 theta is 2 sine theta cos theta. Sine 2 theta is 2 sine theta cos theta. And we're multiplying that by the sine of theta. Nice, we're not doing anything special so far yet. Okay, now one thing is that we need to realize that 2 cos square theta minus 1 times cos theta, that is going to give us 2 cos cube theta, 2 cos cube theta, and then cos times minus 1 is minus cos theta. Okay, we're almost there. And then right here now, sine theta times this is going to give me sine times sine is sine squared. So now I get minus 2 sine square theta cos theta. Okay. Now this is what I get. Now I need to realize what am I trying to prove. I realize that they have a 2 cos theta on the outside factored out, and so I'm going to factor out some 2 cos theta. If I factor out a 2 cos theta, what am I going to be left back with is 2 cos theta out of 2 cos cube. That leaves me back with cos square theta. If I factor out 2 cos theta from cos theta, that does leave me with minus half. Then if I factor out with 2 cos theta from this, that leaves me back with minus sine square theta. Oh, see there, see there, see there, see there. But we know that addition is what? We know that addition is commutative, so we can replace the plus minus a half here, plus minus sine square, and write it as minus sine square minus a half. So now we'll finish. We can rewrite this then as 2 cos theta multiplied by, we're going to rewrite this now as cos square theta minus sine squared theta minus a half. Cos squared theta minus sine squared theta minus a half. Nice and easy. This is now our right hand side. Nice, easy, soft. That's our right hand side. So we'll do the proof now. Nice and easy. That takes care of part 1. Now we can actually go to part 2. Part 2 says using an appropriate formulae show that a half sine 6 theta 2 theta is equal to 2 cos squared 2 theta minus 1 sine 2 theta. So we have another proof to do. They're killing us with proofs. Imagine, my gosh, they just gave us a proof and they want us to do another proof. So I always like to start with writing down what my left hand side is. My left hand side is equivalent to a half of the sine of 6 theta minus sine 2 theta. Now there are 2 ways we can do this. You can rewrite sine 6 theta as something else, or you can realize that you have you're subtracting 2 sines, which is a difference of 2 sines formula, which is twice the cos of half the sum times the sine of half the difference. We can utilize that formula, so it's going to become a half of twice the cos of half the sum. So it's twice the cos of 6 theta plus 2 theta over 2, twice the cos of half the sum times the sine of half the difference. That's how you find the difference of 2 cos. Twice the cos of half the sum times the sine of half the difference. Half the difference is 6 theta minus 2 theta over 2. Nice. Now, once you get to this stage now, you can go ahead and say, all right, not a problem now. A half cancel the 2, and so it just works out to be the cosine of 6 theta plus 2 theta over 2 is the cos of 4 theta. And then 6 theta minus 2 theta is 4 theta, and 4 theta over 2 is 2 theta. So we get cos 4 theta sine 2 theta. That's what we get. Nice. But then look at this now. Cos 4 theta, we can break up cos 4 theta now, as we can write it as cos 4 theta can be looked at as cos of 2 times 2 theta. Cos 4 theta can be looked at as cos of 2 times 2 theta times the sine of 2 theta. We can always look at cos theta like that. All right. Then what is the cos of 2x? That's 2 cos square x minus 1. So this is going to work out to be 2 times cos square 2 times cos square 2 theta minus 1. And all of this is, of course, multiplied by sine 2 theta. Which is equivalent to the right-hand side. Nice and easy. Soft. All right? And so that takes care of part 2. Then now the question says, hence or otherwise, solve sine 6 theta minus sine 2 theta equals 0. So that's part 3. So part 3 says hence or otherwise. We're going with hence. It wants us to solve sine 6 theta minus sine 2 theta is equal to 0. Now, if we're solving sine 6 theta minus sine 2 theta equals 0, then what we're solving is, we said that all of this actually worked it out to be 2 times the cos of 4 theta times the sine of 2 theta. So actually just going to be solving 2 times cos 4 theta times the sine of 2 theta is equal to 0. This is what we end up solving. Now, if the product of two numbers is equal to 0, then what the final solution is working out to be is either cos 4 theta is equal to 0, it's either cos 4 theta is 0, or it must be the other side, the sine 2 theta is 0. Okay. Now we need to pay attention to the argument or the region of the solution. They want theta to be between 0 and pi by 2. So first thing is we draw our circle and look at where cos is positive. Cos is positive in the first and the fourth quadrant. And so we need to find our principal acute angle, or the argument in the first quadrant, which is cos inverse of 0. Cos inverse of 0, that is cos inverse of 0, that's pi by 2. That's 90 degrees, or pi by 2. All right, pi by 2. So what does that mean? That means that 4 theta, is equal to pi by 2, or 4 theta is equal to, in this quadrant, it's 2 pi minus pi by 2. So those are the solutions that we're getting for theta right here. All right. Now, of course, we're going to have to divide through by 4 to then realize that theta is equal to pi by 2 divided by 4 is pi by 8. And then 2 pi minus pi by 2, this is really 3 pi by 2, and dividing through by 4 is 3 pi by 8. So theta can either be pi by 8 or theta is 3 pi by 8. All right, so that's the solution we're getting from this region. All right, so let me put that box. These are part of the answer. Now let's continue with this part. Now, if we're solving sine 2 theta is 0, you can go ahead and draw a circle. And we know that sine is positive in the first and the second quadrant. So when you find sine inverse of 0, your principal acute angle, which is sine inverse of 0, is 0. Sine inverse of 0 is 0. And so if it is 0 in this quadrant, it's going to be pi minus 0 in this quadrant, which is pi. So what we're getting in our values for theta over here is theta is equal to, this is 2 theta. We're getting 2 theta is equal to 0, or 2 theta is equal to pi. So when we divide through by 2, this is telling us then that theta is actually 0 over 2, which is 0, or theta is equal to pi divided by 2, which is pi by 2. So that's the solution. Nice and easy, soft. So these are part of the solution. When you finish now, ideally I like when you put everything together. All right, so just want a little more space to write our answer. I'll put the answer over here. So this is the final answer. So the final answer, just to put it right here, let me put it in a different color. The final answer is theta is working out to be 0, or theta can be pi by 8, or theta can be 3 pi by 8, or theta can be pi by 2. This is the final answer. Nice and easy. So, and if you don't believe your answer, check it. Just check it. Just check it. All right, you can check it. Pi by 8 is 180 over 8, which is 22.5. Check out what is the sine of 22.5 times 6 minus the sine of 45. I get 0. So the first one is, this is right. You can check out 3 pi by 8. All right, so you can check it out. The sine of 3 pi by 8 minus the sine of 2 times 3 pi by 8. And I still get 0. So you can check it out. You're going to get 0 with all of them. So this is the answer. Soft. Okay. Final question. One more equation to solve. Part B. Part B is giving us, find all possible values of the cosine of theta such that 2 cot squared theta plus cos theta is 0. And it says find all possible values of cos theta. It didn't say it wants theta and it said it wants cos theta. So first thing we have to write down is 2 cot squared theta plus cos theta, and we know that this is equal to 0. 2 cot squared theta plus cos theta, this is equal to 0. If 2 cot squared theta plus cos theta is equal to 0, then what do we need to do? What we need to do is rewrite cos as, let's rewrite cot squared as cos over sine. So we can rewrite this as 2 cot squared theta. Cot squared is cos over sine, sorry. There are many ways you can solve it, and you can even use another identity, because we know that cot squared is 1 minus cosec squared. All right, so you can even utilize this identity that cot squared is equal to 1 minus cosec squared theta. That's cot squared 1 minus cosec squared plus cos theta. All right. And if you don't remember these identities, it always stems back from these 3 principles. I know a lot of times we forget these ones. The main one that we remember is sine squared plus cos squared equal to 1. All right, I'm just writing it down over here. If you're to divide this by sine squared over sine squared is 1 plus cos squared over sine squared, and cos squared over sine squared is cot squared, and then 1 over cos, 1 over sine, let me slow it down, I can't pronounce these words sometimes. 1 divided by sine squared is cosec squared. All right, and so this is how they develop this identity from. Then you transpose for cot square, and so cot square is actually, you would make cot square the subject, it's actually cosec square minus 1. So it's a good thing I even look back at it, so I made a mistake right here. It's actually cosec square minus 1. So let me refill that with cosec square minus 1. My apologies there. So, but all of these identities that I want to point out, it stems from the idea of sine square plus cos square is 1. So this is what we're solving, and we're solving for what? We're solving for cos theta. If you multiply through by 2, you're getting 2 over sine squared theta. Why did I change ink? I don't know. 2 over sine squared theta. 2 times minus 1 is minus 2 plus cos theta is equal to 0. Nice and easy. Now when you get to this portion of the solution, what do? Well, you can multiply through the entire equation by sine square. Just do it. Just multiply through by sine square. If you multiply through by sine square, then what do you notice? Multiplying through by sine square, the equation becomes 2 minus 2 sine squared theta plus cos theta sine squared theta, and it's still equal to 0 because why? Sine squared theta times 0 is just 0. Anything times 0 is 0. Alright, so this still gonna give you 0. Then what do you do next? Well, you can go ahead and identify that this sine squared theta is 1 minus cos squared theta. So you can rewrite it now as 2 times 2 bracket sine squared theta is 1 minus cos squared theta. I know I'm substituting a lot of identities. Plus cos theta times 1 minus cos squared theta, because that's sine squared theta. We're almost finished. We're almost finished. Now that we have this and we're almost done, what I want you to do is when you expand this, just expand it right away and see that when you expand it, you're going to get 2 minus 2. Minus and minus become plus, so you get plus 2 cos squared theta plus cos theta plus cos theta, and cos times minus cos cube is minus. Cos times cos squared is minus cos cube theta. That's equal to 0. Now I realize that pretty much I end up with a cubic equation. 2 minus 2 cancel, so I end up with minus cos cube minus cos cube theta plus 2 cos squared theta plus cos theta, and that is equal to 0. So this is the equation I end up wanting to solve. Now, what I'm going to do is I'm going to divide through by -1, because I don't like when my first term is negative. So I'm going to divide through by -1 to rewrite it as cos cube theta minus 2 cos squared theta minus cos theta is equal to 0. Okay, now we're almost finished. All right, now I really don't want to go to a new page, so I'm just going to take away these. I'm going to make some space. Now, if you have cos cube minus 2 cos squared minus cos theta, first thing you need to do is factor out cos theta. That's the first thing you need to do, factor out cos theta. After you factor out cos theta, what you're going to end up left back with is cos squared theta, factor out. When you factor out from here now, you're going to be left back with minus 2 cos theta. And when you factor out cos theta from cos theta, you're left back with minus 1. And now all of this is, of course, equal to 0. So what we end up having to solve is, we're solving either cos theta is equal to 0, or we're solving cos squared theta minus 2 cos theta minus 1 is equal to 0. Now for the quadratic portion, you can just go ahead and use the quadratic formula, or you can factorize it. Why I'm thinking quadratic formula so much? You can factorize it. Factorizing it equals 0. Signs are different, the greater product negative. Let me see, 1 and 1. Did I expand this right? Or should this be a plus somewhere here? Just making sure I didn't expand it incorrectly. Minus 2 plus minus cos cube plus cos square plus cos theta divided through by negative. So this is absolutely fine. Okay, so I guess we're just gonna have to go to quadratic formula. Going to the quadratic formula to solve for cos theta. What we're gonna get is cos theta is equal to, think of cos theta as your x. So it's going to be minus b, which is minus 2, which works out to just be positive 2, plus or minus the square root of b squared, which is 2 squared, which is 4, minus 4ac, which is 4 times 1 times minus 1, 4 times 1 times minus 1, which is minus 4. Minus 4 become plus 4 over 2a, which is 2. So this part is working out to be 2 plus or minus the square root of 8 over 2. But the square root of 8 is really, what's the square root of 8 again? I think that's 3 root 2. Because the square root of 8 can be written as the square root of 4 times the square root of 2. That's 2 root 2. Okay, 2 root 2. So I'm just going to rewrite it here. The square root of 8 can be written as 2 root 2. And so I divide by 2 and I'm going to get cos theta is actually 1 plus or minus 2 over 2 is 1. 2 root 2 over 2 is root 2. So I get 1 plus or minus root 2. Now the 1 plus root 2 can't work. The 1 plus root 2 is not valid. And so the two solutions is cos theta can either be equal to 0. That's one solution. Or the next solution is cos theta can be equal to 1 minus root 2. Cos theta can equal to 1 minus root 2. Now you might wonder, sir, why I left out the plus 1? Cos theta cannot be 1 plus root 2. That is because, let's write it back up here. Don't ever forget this, that the cosine of theta must always be between 1 and negative 1. But 1 plus root 2 gone away. 1 plus root 2 gone way over here, so 1 plus root 2 is 2 point something. That's bigger than 1. So these are the only possible solutions. Nice and easy, soft. So that takes care of question 3. Let's go to question 4. Question 4 says, determine the Cartesian equation of the curve defined by the parametric equation